in that packet that I gave you guys yesterday. So Mara, you're with me. Jeanette, you're testing. Okay, and you're paying attention to calculator active versus inactive. Okay, Andy? You didn't get that packet from yesterday? Okay, I thought I gave it to you, but I didn't pick it up. Thanks. All right, friends, here we go. Okay, for all my friends that went to the AP Summit on Saturday, we did functional analysis. And you're gonna be like, why are we doing functional analysis again? Because functional analysis shows up on every single one of the AP exams, and I want this to be high scoring. So the continuous function f is defined on the interval -5 less than or equal to x less than or equal to 8. The graph of f, which consists of 4 line segments, is given in the figure above. Let g be the function given by g of x equals 2x plus the integral from -2 to x of f of t dt. Okie dokie. Important stuff that we know. This is the graph of f. Don't blow it. Make sure you know what function you're talking about. We've got some other function in the house. G of x is equal to 2x plus the integral from -2 to x of f of t dt. And in part A, you need to find g of 0 and g of -5. Take a minute with the folks around you. What's your plan? How are you going to evaluate g of 0 and g of -5? Over pile over here? Yeah.
Inactive?
This is calculator inactive, yes.
Can you do g of 0 equals 2 times 0 plus that integral? And then you, I don't know, you find the slope at f equals for f at f equals 0. Oh, find the area revolving around the axis.
All right, let's get some hands on this. What are you going to do to find g of 0? What's your thought? Flora, what are you going to do? For the second part, what do you mean?
For the -2 to the x, for the integral.
So, well, just tell me how you would start. To find g of 0, what would you do?
You plug it in.
You're going to plug in what?
For the 0.
You're going to plug in 0 everywhere there's an x, right? So g of 0, rewrite it for me. What are we doing here?
2 times 0
2 times 0.
plus the integral from -2 to 0
Uh-huh.
of f of t dt.
Is everybody okay with the setup, right? This is your opening move. Now, I think I know what's going on in your head, and you're like the ideas about the theorem. But what am I asking you guys to find in this part?
The area.
Area. Just go find the area. What I know is that g of 0 is going to be 0 plus the integral from -2 to 0 of f of t dt. And if I look at my graph, here's x equals -2, here's x equals 0. My limits of integration are going from -2 to 0. We're moving in the correct order here. So what's that area? It's a trapezoid, and the area of a trapezoid is 1/2 base 1 plus base 2 times the height. The bases are the parallel sides. They have to be the parallel sides here. So the first base is 2, the second base is 1, and that height is 2. 2 plus 1 is 3, times 2 is 6. Cut it in half, you get 3. If you've got g of 0 is equal to 3, congratulations, you just picked up the first point. That's all there was to that one. How many guys picked up the first point? Maybe I didn't give you enough time to pick up the first point. All right, so with that said, go get me g of -5. -10 plus your integral from -2 to -5 f of t dt. Another area computation, a little bit different. Jesus, what's going to mess some people up here?
The what's it called? The negative area.
Wait, you said the negative area?
Negative area.
The negative area. Okay, so we're going from -2 to -5. So there's definitely some negative area that's going to mess people up. But there's something else that's really going to mess people up if you're not paying attention. Kevin, what's the thing that's going to mess some people up?
From -2 to -5.
You're going from -2 to -5. You're doing a like right to left computation, which is not the right way that we want to do a definite integral. You want to be going left to right. So we're going to flip it, and that's okay. But you've got to do the negative sign, so you're doing the integral from -5 to -2 of f of t dt. And then from there, find the area, this guy's negative, find the area, this guy's going to be positive. So we've got -10 minus area here, what is that, 2 times 4 is 8, cut that in half, so that's -4. Area over here is 1 times 2, cut that in half, plus 1. Simplify if you want to, and I think you get -7. But I would also encourage you guys to just stop right here. There's no need to do anything else. So you would get 1 point for coming up with g of 0 is equal to 3. A second point for getting that g of -5 is equal to -7. I would hope this is a really kind, friendly, we know what to do here kind of question. All right, let's keep going. Part B. Find g prime of x in terms of f of x. I need g prime of x in terms of f of x, then find g double prime of 4 and g double prime of -2. I'll give you a little bit more processing time on this one. So g of x is 2x plus the integral from -2 to x. We need g prime, we need the derivative of that expression. G prime is the derivative of this expression 2x plus the integral from -2 to x f of t dt. How am I going to take the derivative? Derivative of 2x, what's going to happen here? Derivative is going to be 2 plus the derivative of that integral from -2 to x of f of t dt.
d over dx, and then that 1
Okay, I mean, you could write it that way. You could say it's the derivative from -2 to x of f of t dt. Flora, I think this is what you may have been thinking about earlier. What were you thinking about earlier?
Something calculus theorem.
It's the something calculus theorem. Yeah, it's something. It's the something calculus theorem. You're taking the derivative of the integral of a function from a constant to a variable. Destiny?
Is that the same thing as saying f prime of x?
It's not that this is equal to f prime of x. If you're taking the derivative of the integral of a function, it's just the original function back. That's the second fundamental theorem of calculus. So this is just going to be 2 plus f of x. The good news is you don't have to name the second fundamental theorem of calculus. You just need to recognize it when you see it. Derivative of the integral of the function from a constant to a variable, you just get the original function back. So g prime of x is equal to 2 plus f of x, first point. Now we need G double prime of 4. Where does that come from? What do you want to do? Okay, if I want G double prime of 4, it's a two-step process. The first step is go find G double prime of x. We already know that G prime is 2 plus f of x, so what's G double prime?
F prime.
It's just f prime. So what's G double prime of 4? G double prime of 4 is f prime of 4. Paul? You what? You don't need a number. Oh yeah, I'm not saying that we're done here with f prime of 4. But what we know is that G double prime and f prime are the same thing. So G double prime of 4 is equal to f prime of 4. Then how do I get f prime of 4? You want to find the slope. F prime means the derivative. So you find the slope. Well, where's 4? 1, 2, 3, 4, somewhere about here. What's the slope of the tangent line right here?
Negative 3 minus 3.
Right, I'm on a line segment. The slope is going to be the same all the way through. So even if you can't find it exactly at that point, you could do what Henry just recommended and say, okay, I've got a point and a point. So I could say 3 minus negative 3, change in y, over 2 minus 8. And I would not simplify that at all unless you really want to. 3 minus negative 3 is going to be 6. 2 minus 8 is negative 6. So you're going to get negative 1. Okay, what about G double prime of, what do they want? Negative 2? Okay, well what do we know about G double prime of negative 2? That's going to have to be equal to f prime of negative 2. What's the slope there? 0? What's the slope of f at negative 2?
Because it took us 1.
Kevin's recommending 0. I'm hearing it. I'm hearing whispers from the angels on the side. Or maybe it's the demons on the side. I'm not sure. But it was somebody on the side. F prime of negative 2. Slope at negative 2. Gerson, what do you know?
It doesn't exist.
Why not?
It's a cusp point.
Because your graph, right, at x equals negative 2, your graph has a cusp point. It has a sharp point, which is why your derivative doesn't exist. Different from saying slope of 0. So f prime of negative 2, I would say, does not exist because f has a cusp point at x equals negative 2. 1 point for coming up with the derivative, 1 point for G double prime of 4, 1 point for G double prime of negative 2. Okay. See what you can do with part C. Concave down. What does that have to mean to you?
G equals that's why. That's underneath it like this. G equals up.
So if G's concave down, I'll take anything from anybody on this one. What do you know for sure? Something you can go with. Henry, what do you know?
G prime has to be positive.
G prime has to be positive? I disagree. G is concave down. There is something that's true about G prime, but
Oh,
it's not that. Give me 1 second. Henry, what do you know for sure? If G is concave down, what has to be true about G prime?
F has to, no. The original function has to be, decreasing? I think.
Okay, hold on. You've got all the right thoughts, but I think they're coming out in the wrong way. G is concave down. What's true about G prime? G prime is decreasing. Right? You're going to make sure you tell me the right thing about the right function. So where is G prime decreasing? Well, I don't see G prime anywhere. But G prime is F. Right? So F is decreasing. Wait, is that true?
No.
G prime and F aren't the same, are they?
Yeah.
G prime and F are not the
No,
same.
G double prime.
There's no G
No,
plus.
never mind.
It's
G prime
2x
and
point,
F of
G
x.
prime is 2 plus F.
Yeah, we've got to be careful here. G prime is 2 plus F of x. G prime and F are not exactly the same. Right? You've got G prime is F of x plus 2. Well, what does that 2 do to the graph?
Pulls it up.
It's a shift up, right? So where is F decreasing? F is decreasing from -2 to 0, and we're decreasing from 2 to 8. What if I took that whole graph and I shifted it up 2 spaces? Still the same thing. So it's still the same interval, so what do we say? This is going to be from -2 to 0, and then from 2 to 8. Tell people how they awarded points here. Oh, they just said 1 point if you get it right. Okay. So 1 point. All right, last one. Part D. The function h is given by h is equal to g of x cubed plus 1. Find h prime of 1. This one's worth 3 points. See what you can do with this. Alright, some good things that I'm seeing so far. We know that h of x is equal to g of x cubed plus 1. So h prime is going to be g prime of x cubed plus 1 times 3x squared. Chain rule. A lot of folks are doing well there. To find h prime of 1, well now I'm going to plug in 1. So 1 cubed is 1 plus 1 is 2. G prime of 2 times 3 times 1 squared. To get g prime of 2, where's that going to come from?
2 plus F.
Right, we know from earlier that g prime of x is equal to 2 plus f of x. So g prime of 2 is 2 plus f of 2. F of 2 is, what is that, 3? So we've got 2 plus 3, this guy over here is 5. So this is 5 times 3 times 1 squared, which is 15. If you correctly found the derivative using the chain rule, they gave you 2 points, and then 1 point at the end for the final answer. And I'd say this is a pretty typical functional analysis question. They're gonna mix things in on you. Don't be surprised. You know, I think a lot of folks were successful with part D that maybe weren't as successful with part C. If you hit a, whoa, what word was that? If you hit a point in the question, like, I just don't know, keep going. Do what you can. See what's gonna happen. Everybody okay? All right, so tonight's homework is question number 6. And if I'm thinking about question number 6 correctly, question number 6 is a separable differential equation, which is something that not too very long ago you guys were really good at. So separable differential equation, slope field, all these things are fair game. We're gonna stop filming now and we're gonna move into the practice multiple choice part.